I'm going to introduce to you Neal Brooks. Hello, Neal.
Hi, how are you, everybody? Scoop and everybody else that's in the audience watching us over the internet.
Well, so far, I think everyone is happy. Seeing the conversations in the chat, I think it's going fine. So, Neal, you've been working with Symfony since 1.4.
Yep.
So yes, I've been preparing a talk for another conference about the journey from Symfony 0.6.7 to currently 5. Back in the days, Symfony was interesting.
Yeah, yeah. I mean, it was very opinionated back in the early days, and obviously you had the active record pattern with the ORM and everything, and then it was a massive shift, wasn't it, to 2?
Yes, yes, that was.
Yeah, I remember when at the London conference when Fabian announced Symfony 3, but it was when Symfony 2 had just come out, and he was actually just announcing that the release plan, moving forward, the six month releases. But he said, right, today I'm going to announce Symfony 3, and I thought, well, hold on, I haven't even got to grips with Symfony 2 yet. How am I going to manage that paradigm shift between that? Yeah, but I mean, that was a long time ago now. But I think we've seen some opinionated factions coming back into the framework. Nowadays, so it's interesting to see that kind of evolution go one way and then start swaying back towards the other.
Yeah, exactly. So you're also a co-organizer of the Symfony user group in the UK?
Yeah, so Jakub Zalas has been running it for forever, for as long as I've been part of the community. But I think, I mean, I'm starting to. I've been involved since the start of this year, and I'm beginning to kind of figure out how difficult it can be to run some of these things.
It's an interesting year to start doing user groups.
Yeah, and we've had to, but we've had to like totally embrace the fact that everything's online now, the same as this conference. But I think it's great because you can just reach so many more people. There's so much more potential. You're not limited to 30 or 40 people in a room. You've suddenly got like 100 people like joining online, and everybody's learning something and bringing something in. You can obviously bring in speakers that you wouldn't otherwise be able to, which I think is a really cool thing. It's you have to embrace the change.
Let's introduce your talk, because you're going to be talking about DDD and Symfony. Now, DDD and Symfony has become more popular over the years, it seems. Why? Or are you going to talk about that in your talk?
Not necessarily about why. I think it just becomes as people hear about DDD as kind of like it's the next level up, really, isn't it? From kind of doing creating just websites and stuff that does something. It's more focused on actually solving real problems rather than just kind of storing state in a database. It's more about actually, am I doing the right thing for the business, and I'm creating an actual application rather than a website with a database on it. So I think, as people maybe get wind of the problems that you can solve with DDD, then it's bound to become more and more popular. Okay,
well, I'm giving you the stage. Enjoy.
Fantastic, thank you. So everybody, thank you so much for joining me today, and thank you to the organisers for allowing me to come on and throw my slides onto your screens. And so today we're going to look at the absolute beginner's guide to domain-driven design with Symfony. And if you're new to DDD, or even if you're familiar with the concepts but not sure how to implement it with Symfony, which is where I started a long time ago, kind of trying to think about DDD. And I went to a workshop and then finished that workshop, and then for years had no hands-on practice and had no idea how to do this stuff and to bring it into Symfony. Or if you're not sure how the components slot together, then stick around. And we do have quite a lot to cover here, and a fairly short amount of time. But I'm going to try not to go too fast. I understand that English is probably not the first language for a lot of people in the audience, so I'm going to try and slow down. I do tend to go fast when I'm excited, and I'm very excited to be here today. But I will try to bear that in mind. But don't worry if you can't keep up all the way. You can always come back and watch the video later on, and I'm going to share code examples with you at the end as well. So we'll start off with asking, what's the point? And we could ask two questions here. What's the point in DDD? And what's the point in this talk? So what is the point of DDD? It all started off with the Blue Book, as we know it, by Eric Evans. And it does what it says on the tin. It just shows us how to tackle complex business systems in software applications. So then what's the point of this talk? There's been several books on DDD. We've had the Blue Book and the Red Book and the Greenish Blue Book. And there've been loads of books. And if you go and read them, you don't need me, like this talk is over, right? But actually, I mean, we can get started with just the basics, just armed with minimal understanding. But not many books give you a direct line into DDD with Symfony, which is where I was coming from before. I'd learned the terms and thought I understood stuff, but I needed actual examples of how to do this with Symfony. Now, the ideas in this talk are a jumping off point to get you started. We're not going to go exploring into too much depth. So we're not going to touch event sourcing or anything overly complex today, because what we need to do is get comfortable with the basics before we start making it harder for ourselves. And you can always get some experience or get some practice with the stuff that I'm going to show you today before you then move on to more complex thoughts and notions about design, domain-driven design. So we're going to start off very first point, asking what is domain-driven design? Now, DDD is an approach to understanding the business in order to represent it in software, and also an architectural pattern for simplifying business problems. And it sounds scary, but actually it's pretty simple once you get familiar with it. So to begin with, we'll start off by defining and revising some terms quickly, but then we'll see each of these examples in action. Now, understand, obviously, we've just had the coffee break, and I believe that coffee takes about 20 minutes to kick in, so you should all be super alert by the time that we get to the code examples. So first of all, the domain. Now, the domain is the business or the company or the industry you're creating software for. It's got nothing to do with web hosting or domain names. And there are domain experts working in any given company. Now, this could be anybody with relevant experience in their role for whatever system that you are modeling at the time. So, for example, if you're building software for a nursing home, then a domain expert could be a carer or the admin manager or the cook or the cleaning attendant. It depends on the problem you're trying to solve in the software right now. And domain experts will all have processes and experiences for carrying out their own jobs, and it's your job to replicate their knowledge in your system. The ubiquitous language. Now, ubiquitous means found everywhere, and the ubiquitous language is the language that is commonly used and understood by everybody in the business. Now, the first few chapters of the Blue Book go into this in great depth, and it gets really repetitive about it. It is really, really important, but the only thing that you need to know is that the software must use the same words as the business. Now, the crux of this is that you need to work with domain experts to discover objects and processes that occur in the business domain and what terms they use for those objects and processes. And you use those same words for your entities and services and method names. So everybody must understand the same meanings of things. And when there's a conflict of terms between the business understanding and the technical understanding, the business words trump the technical words. So, for example, on this, if the business uses phrases like the customer confirms the order, don't have methods called set order status. You need to call your function confirm order instead. And then you need another function called cancel order. And then you stop and clarify and redefine terms when necessary. Now, sometimes you realize halfway down the road that you picked some ambiguous name for some object or event. And so you need to go back and fix that, because it's easier to fix an incorrect class name in the first place than it is to try to remember all the nuances in your system where you got the naming scheme wrong. And then finally, think about this. Do the people in your company call their clients users or customers? And if your company calls them customers, then why do we, as tech people, insist on creating classes called user? It just doesn't make sense. Now, as an example, many years ago, I was building software for estate agents. Now, I called every house and flat and building in the system a property. But what I didn't know was that estate agents call them instructions instead. Now, for ages, I tried to convince them that they were the ones in the wrong. And we went back and forth because in my experience as a renter and buyer, I'd always called houses properties. But actually, we were both right in our own way. Now, in the estate agent world, houses are called instructions. But to everybody else, they're called properties. And our job as software engineers is to find out the correct name for things in each context, which brings us on to bounded contexts. Now, we've just seen that the ubiquitous language can help us discover logical separations in the code, and that some objects have got different meanings and responsibilities in different contexts. So for another example about the differences between contexts, if we had some traffic light management software, we think it doesn't care about the specifics of each car that passes through the set of traffic lights. It just cares how many cars have been through there within the hour. So details like the model or the color or the engine size are completely irrelevant. And the car is the least important object in this model. But a car dealership would want to know a car's model or its age or its color, the engine size, any optional extras, etc., all as high-level selling points. Now, the car is important to some degree, but maybe to the dealership, the most important object is the sale object. And then a mechanic doesn't care about a visual design of a car, but does care about the engine management software and the braking system. Now, you can see that the importance and role of the car is different depending on the context that we're in. And it would be absolutely crazy to try to model a single car object that can handle all three different contexts. But with flat red style development, this is what we end up with. And if we tried to create a monolithic application for a dealership, which could also book cars in for service and repair, we'd probably end up with some big car object that has all the sale information linked to it, as well as having the servicing information. So the car object would have all these different properties on it because it'd have to deal with both cases, both the high-level selling points as well as the detailed service information. And it violates the single responsibility principle because it's got too many reasons to change. And without domain-driven design, it's very difficult to manage these changing responsibilities and mess effectively. But with DDD, it becomes much easier. So summarizing there, a bounded context is a logical boundary around some behavior within the business, and it's a bubble of functionality. Now, the closest analogy that we have to that would be the self-contained bundles that we used to have in kind of Symfony 2, Symfony 3. And for an online store, let's think about that. Some bounded context might be invoicing or stock ordering or shipping or product recommendations. Now, each of those four areas would have some concept of a product, but a product object would have different methods and properties in each. And we have to understand where the separations are. And bounded contexts are not allowed to talk directly to each other, and they're not allowed to know anything about each other, because that would just be messy, really messy, and would make the entire process of DDD redundant, because you may as well just go back to mapping big God objects directly into the database, which is what we're trying to avoid. Now, entities. We're used to dealing with Doctrine entities, but what's an entity in domain-driven design? Well, a DDD is an entity which has some sort of identity, which makes it unique. So, for example, a pair of identical twins have got exactly the same physical attributes. They've got the same hair color, the same eye color, the same height, the same blood type, right down to the genetic level. And their properties are identical, but they're not the same person. The identity is something intrinsic to them both, and they are both individual entities. Now, the identity cannot be changed, even if their properties about them can be. So they could change their hair color, they could, I don't know what else they could, they can't really change their eye color, but yeah, or their blood type, but they can change their hair color, but they're still the same person. They still have the same identity. And the ID doesn't mean an auto-incremented ID from the database either. We need our entities to be able to work independently of the data storage mechanism. And additionally, in Symfony, we're used to entities being flat mapping classes, which often just act as some sort of data representation. And then we usually push functionality into the controllers or into the repositories because we can't tell where else it should go. But in DDD, they're much richer with properties and functionality, and they don't have anything to do with the database. And we'll see how this works a bit later on. Now, aggregates and aggregate routes are one major aspect that I really struggled with when I was reading the book, and it took explanations from a couple of people to help me understand it. Now, an aggregate is a collection of objects that represent one concept in the domain. So, for example, in the bounded context of a mechanic, we could say that the car is an aggregate of lots of smaller objects, like the engine, the gearing, the braking, the dashboard, and the power steering. And these all form the single concept of a car aggregate within our worldview. And you can have multiple aggregates in a bounded context, but they can't talk directly to each other. They can communicate by emitting and or subscribing to events. But maybe within a payments-bound context for a retail store, there could be an aggregate for payments received, an aggregate for payments outgoing, an aggregate for bounced payments, or an aggregate for credit accounts, these kind of things. They're all related to payments, but they're different objects and different aggregates themselves. So what then is an aggregate route? Well, the aggregate is the entry point into the aggregate. So every interaction between the outside world and the domain must take place through the aggregate route. So how do we know what the aggregate route is? Well, the aggregate route is the class which the aggregate is concerned with, the thing that we're trying to create or manage. So in the mechanic context, the car would probably be an aggregate route because the works are carried out on that particular vehicle. The engine could perhaps be another entity in that aggregate, as it would presumably have its own identity stamped on it, but it wouldn't be the aggregate route. There might also be value objects to represent the power steering system or the gearbox, but the car is aggregate route because even if the engine is being fixed, we consider the works as being carried out on the car. Now, in the dealership, maybe an aggregate route would be a car sale object or an order object. We don't care which individual car is sold, just the model and the color to order from the factory. We can have a car object, but it won't do anything apart from hold data about what wheel size, etc., was chosen by the customer. And in the traffic light management system that we had, maybe the aggregate route would be an object representing a single set of crossroads with multiple traffic light entities to manage. And the car might not even be an object of its own here. It could just be an incremented property on some other object as the cars are counted as being passing through. Invariance is just a posh name for business rules. These are things that must or must not happen in the business logic. Domain invariants are protected in the domain code, and they're different to application rules. So, for example, a banking domain invariant would be that a cash machine must not give you your money before it's checked that you've got enough money in your account for the transaction. But an application level concern in a cache point would be that checking that the card is readable or that the PIN is correct. Now, the important thing is to work with domain experts in the business to discover what those invariants are. Now, domain services and application services are both defined in the DDD book, and at first it's confusing and difficult to remember, and it's easy to get mixed up. Domain services contain domain logic, which doesn't naturally fit within an aggregate or an entity or a value object. And it's got full knowledge of the domain, and it can call methods on aggregates. Application services orchestrate execution of domain logic according to outside world input, but they don't contain domain logic themselves. The external application is allowed to talk to application services, and the application service is allowed to talk to the domain. And the key thing to remember is in the naming here. Domain services live in and communicate with the domain, and application services communicate with the domain on behalf of the external application. And we're going to see examples of both of these, so don't worry. So with the revision out of the way, and hopefully with your coffee kicking in, let's think about DDD architecture. Now, the book defines 4 layers of architecture within DDD. We've got the domain layer, or the model layer, which contains all the business logic and the invariants, and the entities and the domain services and the interfaces which allow us to wire in communication with the outside world. And it cannot know about anything outside of its own little bubble. The infrastructure layer contains code which provides the concrete classes for the domain code to use, and it can only depend on the domain layer. And the application layer, which we just spoke about a moment ago, provides services which facilitate communication between the outside world and the domain. So classes within the application layer are allowed to depend on domain entities, such as the aggregate route, and may call domain services. But it cannot contain domain logic or check invariants. It's only allowed to perform validation, such as, does this entity exist, before I try to call methods on it, but it cannot do anything more complex than that. And it translates simple variable types from the outside world into domain-specific object types. And the UI layer can only talk to the application services, and it must not know about any objects within the domain. So it only talks to the application layers through purely simple data types, such as native PHP types or data transfer objects. And we're going to see a DTO later on again, so don't worry about that for the moment. So let's get started doing this with Symfony. Well, straight away, I'm going to simplify each bounded context by getting rid of the UI layer. Symfony's got a perfectly good UI layer in the app namespace, and we can take advantage of that by moving the UI out of each bounded context bubble and sharing it across everything. And that way we can reuse the controllers and the console commands, which will feel much more familiar to us. So let's get on to building something now. Let's imagine we're making an online appointment and diagnosis system for a vet surgery. And we've been talking to the domain experts about what a pet is. So one domain expert, the receptionist, says that a pet is nothing more than a name in his world. He doesn't need to know details about the animal in order to book a slot on a calendar. He just needs to know what name to shout out in the waiting room and at what time. But the vet says that the pet is very important. She records notes on the animal and measures its weight and diagnoses illnesses and takes its age into account and prescribes treatments. The pet is central to the consultation process with the vet. So it looks like we've got one clear bounded context for scheduling appointments here, where an owner can book an appointment to be seen by a vet. And we've got another bounded context for consultations, where a vet can make a diagnosis on an animal and record properties about it. So how do we begin to implement this with Symfony? So if we create a new project, I went for the whole shebang here rather than going minimal, but you could just go bare bones and add components as you need them. But for the purposes of this, let's try to get as much as we need straight away. So ignoring bin, translations, var, and vendor, we're left with this directory structure. And if we open the source directory, we have all the familiar folders. But because we're taking the app namespace to be the UI layer, this means that we've already got this directory polluted with UI level concerns. So let's just put everything in the app namespace into an app directory. But we've got a bit of config to sort out now. So in the app kernel, I need to adjust some paths to make things work again. And it's just adding some dots and slashes. And I need to tell the autoloader where I've moved the app namespace to. And now the service configuration needs updating to recognize the new path. And Doctrine throws a wobbly unless you update the path it's looking for its entity classes in. And then finally, we need to update the routing config. So now let's think about adding the appointment context. Now that we've got the housekeeping out of the way, we can start building our first bounded context. So I'm going to start by adding a new namespace to the Composer autoloader, corresponding to the Acme vet directory I just created in source. And also removing the app prefix from the tests loader. I'm going to put all the tests in the same place, but I don't want to lump them all under app tests. Remember, not everything is app. We've got our own names, our own DDD namespace stuff going on now as well. So it would be, it wouldn't make sense to put them under app tests. So now let's create the scheduling bounded context. And we put the remaining 3 DDD layers inside it, the application, the domain, and the infrastructure. Now, remember that the app folder is our UI layer, so we don't need to include it here. So how do we start building the aggregate? Well, a great way to start designing the aggregate route is just to write the invariants out in a test class. So let's say that we've got some invariants here. We've got a single appointment must be 15 minutes in length, and that a double appointment can be booked, but nothing longer. And 2 appointments cannot overlap each other. So here are some invariants just listed out as empty test cases. And we can fill the tests in as we begin to build and design our bounded context. So we can design the external API to our aggregate route in the test class. Now, testing creating an object is the easiest one to begin with, so we'll start with that. And one thing to note here is that we encapsulate the identity for the entity as an immutable ID object and pass it into the aggregate route. And we do this, like I said before, because entities change and evolve over time. For example, in this example, confirming an appointment slot or changing it or cancelling it, they're all modifications, mutations on the entity, but the identity needs to stay the same all the time. And it's okay to have this as its own object. In fact, the identity object allows us to distinguish between otherwise identical entities, which was the example we had before with the twins. And here's where we create a pet. Now, remember, in this context, it's nothing more than just a value object. And we'll have a look at that in a minute as well. And we can start building out the appointment class here. Remember that this is the aggregate route for this aggregate in the scheduling bounded context. It's the thing that we want to achieve, which is creating an appointment. But something is a little bit odd here. The constructor is private. Now, why would we do this? Now, I'm sure some people are going to be familiar with this pattern. We want to disallow people from being able to call new appointment. So how do we do that, and why would we want to? Well, we've got this static method on the appointment class, and this is called a named constructor. And you can see that we're protecting one of those invariants that we listed in our test class here, where an appointment must be at least 15 minutes long. And another invariant is protected here, that appointment can be double length. And a third invariant, that the appointment length must be an exact multiple of 15 minutes, is protected as well. And then finally, we return a new clean object at the end. So what does that mean? Well, it means that using named constructors keeps all of the rule checking within this class where it belongs. We don't need to do external validation. It also means that all of those invariants around the appointment are satisfied before we've even created the object. And we can never create an object in an invalid state. We've already checked its validity before we get to this point here in the code. And we don't need methods like is valid on the object, and the client code can confidently use the object, knowing that it's valid and correct at all times. Now let's have a quick look at the appointment ID class. We've got a dependence on Ramsey UUID here. Now, is it okay to depend on external libraries in your domain? Well, ideally not. But UUID is so widely used nowadays that in our domain, we can choose to consider it to be a language level feature. We could always create our own version of UUID or create an abstraction. But as long as we understand the trade-off we're making, we can justify that. And we've got two named constructors here. So far, we've used that generate method in our test class, but we'll come to using from string in just a little while. Now, the pet class is just a value object. It doesn't do anything apart from hold data. And we create it using just a pet's name and a pet owner's name and a contact phone number. And then along with the appointment and the appointment ID, we've created our aggregate. And we have an exception here, which is, the appointment length is invalid. And along with that, our model for this is complete. So let's create our first domain service. It lives in the domain layer and knows about domain objects. And that's why it's called a domain service. A domain service acts upon the aggregate route. And here we've got a service to confirm appointment slots. So it can call methods on the aggregate, and it can contain domain logic. Now, the domain logic within this service is checking that the appointment time doesn't overlap with any already existing appointments in the repository, which was one of the domain invariants that we discussed earlier. But look, we've got a dependence here on something external, and it's the first time we've seen a hint of something from the outside world. But the domain, as we've said, isn't allowed to know anything about anything outside of the domain layer. So how do we deal with providing something external, but keeping all dependencies within the domain bubble? Well, we use an interface. And I know that Samuel talked about interfaces in his talk just now in the testing. And now this is another use for interfaces here. Now we can use the dependency inversion principle, which means that the domain specifies what it expects to be given, but doesn't care about the actual implementation of it. The repository could be a class pushing data to a database, or storing things in memory, or writing to a YAML file. It really doesn't matter. All that matters is that the domain service knows it's going to receive a repository class of some sort, which has got the methods on it that it needs to be able to call. And this is where the domain is saying, I expect that whatever actual class you're going to give me at runtime is going to have these three methods on it that I can call when I need to. But I don't care one bit about how these methods are actually implemented. And the interface stays within the domain. And we're going to configure Symfony's container to provide the external implementation of it. But Isn't the container part of Symfony and therefore part of that UI layer that the domain can't depend on? No, it's not. The DI container is part of the inversion of control, which is separate from the UI layer, because inversion of control calls your code, it orchestrates your code. Your code isn't depending on the container in the slightest. It's completely reversed. So that's how we can get away with that. And in our tests, we can use an in-memory implementation of the interface, which I've called the in-memory appointment repository, and using that same naming convention that you saw in the previous talk, we just call it in memory because it allows us to instantly recognize what it is. Now, this repository just stores the appointments in an array during test runs. And by keeping the concrete classes named after exactly what they do, we can remove a lot of unnecessary mental overhead that we would otherwise have in figuring out what some weird class name represents. So now we're able to create and confirm an appointment in the domain, but we've still got a few things to do before it's actually usable. How about getting information into the domain, or storing the data in the database? Or how do we display appointment information to the user? Well, let's start with the infrastructure here. Now, I've made a repository class within the infrastructure layer. I've already thought about the columns in the database table according to what information I need to store. Now, the use case is so simple here that we can just store everything in one table. We just need the appointment ID, the pet name, the owner contact information, the owner name, appointment start time, and the appointment length if it's a single or a double appointment. Now, repository class implements the same repository interface from before, which, remember, lives in the domain. Now, I've prefixed it with DBAL because we're going to use Doctrine's DBAL connection in this class, and the naming convention is the same again that we've just seen. But there are two questions left to answer here. First of all, how do we wire in that connection? And secondly, we haven't touched anything database yet, so what's going on here? This is a bit fuzzy. And I just want to point something else out in this repository class as well. We return the aggregate from the repository in the same way that we created it initially, except we finally get to use that from string method that we had on the appointment ID. Now, as far as I know, Doctrine ORM uses reflection to reconstitute your entity objects with state. But our approach is actually a lot simpler. So let's just deal quickly with wiring the appointment repository into the container. All I need to do is tell Symfony to auto-wire everything it finds in the Acme Vet namespace, and then we can let the framework do the rest of the magic for us. Now it's time to set up the database table for this context, and we can use Doctrine migrations to take care of the low-level stuff for us. So in this migration, I'm just writing the create query for my table schema. But you might already be thinking this, why aren't we using the ORM? Well, the ORM is overkill for creating a single flat table. Why should we bother mapping an entity class and incurring the overhead of loading the ORM for something so simple? And having run that and created our database table, we're getting closer to the goal. And now we need a way of allowing the UI to communicate with the domain. And we've got the domain logic in place and the infrastructure set up. So now we just need to put data into the database. And we use application services for this. So in the same way that domain services are the services that the domain can use, application services are services that the application can use. And we're going to touch on CQRS now as well, starting with commands, which allow us to get information into the domain. Now, CQRS, if you don't know, stands for Command Query Responsibility Segregation. And it basically means that we separate writing to the database from reading from it. So instead of having code which writes to the database and immediately returns some updated object to your controller, we consider the writing and the reading operations to be completely separate from each other, and we treat them as such in our code. So this is a command class. It's nothing more than a placeholder for data, and the command handler pattern is well documented in Symfony Messenger component, so we're not going to explore it deeply here. There's enough documentation around that. But it can't depend on anything inside the domain, and it can only use simple types in its API, in its interface for the outside world, for the UI layer. Basically, you use native variable types such as dates and integers and booleans, etc., because the UI layer is going to talk to this class directly. And the handler for it is the application service that we were talking about. It's allowed to know about things which exist in the domain. and it translates the simple input from the outside world that we got via that command object into domain objects. And it's allowed to call domain services and call methods directly on aggregate routes. And this is where we're telling the domain to do something. And the basic thing to remember in the application services is to tell, don't ask. And what we mean is that we don't first ask if the domain is able to do something related to domain logic. We just tell the domain that we want to do it and let the domain tell us via exceptions if it can't. So here we're handling any cases where the domain says, no, I can't do that. Remember to tell, don't ask. But with that said, we are allowed to ask questions of the repository. So if this was a command handler for rebooking an appointment, maybe to update the time or the length of the appointment, then we could have to check into this class that the appointment exists in the database first before we then go and tell the domain to rebook it. We can do basic validation here, but we're not allowed to enforce domain invariants in the application layer. Now, the only thing that we need to do for wiring this in is to tell Symfony that the appointment booking handler is available to listen for commands through the message bus. And we do this by adding the messenger.messageHandler tag on it. And then Symfony will do the rest. And now we can finally use our new bounded context. And we've already done all of the hard work. Now, straight away, we're back in familiar territory. We're in the controller. Well, what's going on here? Well, I've created a form type class. And if the form submission is valid, we'll create a new appointment booking command. Remember, that was in our the application directory within our bounded context. And we dispatch that through the Symfony message bus, where we let that application service, which was the handler, deal with translating the information into a domain object and then calling the domain service, which persists it into the database via the DBAL repository. Now, the form is nothing special at all. It's just a bog standard Symfony form type. And we should add validation here, though, but we can worry about that at a later date. Now, if we fill in the form and submit it, we do have data in the database, but we can't see it. So how do we fetch information back? Well, this is the query part of CQRS. Remember, command query responsibility segregation. And we do use something called a query object for this. Now, this is another application service, which, remember, is allowed to use the domain layer and domain services. So we can ask questions of the repository here, and we're allowed to know about the appointment object. And we can call methods on the appointment object. But because this is sending information back to the UI layer, it's not allowed to return the appointment object directly. The information must be translated back to simple native types or a DTO. And a DTO is just another dumb value object, which holds data to cross boundaries. And that's why it's called a data transfer object. Now, everything in a DTO is just simple types like strings or booleans or integers or date times. And it forms a structured representation of data, which is the contract between the application layer and the UI layer. Now we just need to include that query object in the controller. And we can use dependency injection again for this because we've already auto-wired it. And we can get all the appointment DTOs back from the repository. And now we can see appointments. And we can submit more and more and more. And that's great because we've got a functioning bounded context here. But there's a lot of work that we haven't done, like adding validation at the UI layer or creating domain and application services for cancelling or rebooking the appointments. And then maybe you can add those later for some practice. But what about the consultation bounded context? All right, we're not going to go into it all the way here because we don't have time. But we're going to see one fundamental difference between the two in just a moment. And now we're out of the scheduling context and into the consultation. And it's a brand new blank canvas in a brand new world. And we've got the same empty directories created inside it because the domain infrastructure and application layer structure is our framework for creating the bounded context and the aggregates. And remember, the bounded contexts are completely separate apart from where we're sharing the UI layer. The new bounded context cannot know anything about the scheduling context. And the only thing allowed to talk to both contexts is the controllers and the console commands in the app directory. Now, we might decide that in the consultation context, we have a pet aggregate, and we can add details about the pet, or record a consultation with the vet, or add notes, or add diagnoses, etc. And it looks much more like an aggregate route in this bounded context than it did in the scheduling context. And it's a much richer class. And this is because the role of the pet changes depending on the context. Remember, in scheduling, it was nothing more than a name to be shouted out at the correct time for the appointment. But here we've got so much more information about the pet because it's more central to what the vet needs to achieve. And DDD forces us to consider the roles and the purposes of the things that we're building in much greater depth than the RAD style that we're used to. But hold on though, what about user management and storing authentication data in the database? Well, with our domain concerns properly separated from the application layer, we can still use the ORM for managing user login information. In fact, it probably makes sense to do that because it's a lot easier to manage the application that way. So everything which isn't domain related can be done in exactly the same way you used to. You need to decide what fits into your domain logic and what's an application level concern. Now here, I've still got that user class within the app namespace because we want to keep the application level stuff out of the domain. The domain we looked at today doesn't care at all if the vet has got role admin or role user. So there's no point at all in putting it into the domain. We can easily, like we've done here, create a user class and keep that in the app namespace and keep everything going the Symfony way just by cutting and pasting examples from the Symfony docs like we're used to. It just has no place being in the domain. And that leaves the application layer stuff way out of the domain logic. So think about your own business. Do you only say users when you're talking about people interacting with the website? Are they customers or clients or buyers or sellers or any other name to everybody else in the company? Now, this, if they are, this could be a strong indicator that you've got a boundary between application and domain concerns here. And it's up to you to explore these and figure out what information you're sending through in your web applications that the domain does need to know about or doesn't need to know about. You need to split those application concerns from the domain concerns. So in order to get started yourself, you need to think about the words that you use in the business, and you need to identify the bounded contexts and think about who the domain experts are for each of those bounded contexts, and start talking about business processes and invariants in each bounded context as well. And then identify the aggregates and start building the software. Domain-driven design means having a lot of meetings with a lot of people to make sure that you're building the software correctly and that it lives up to people's expectations about how they're going to use it for the business. And there's been a lot here. So if you've kept up, then well done. If you didn't, that's not a problem. You can clone my repo, you can have a walk through the code, and you can look at the commit history. Now, I committed the examples in the same stages that I showed you here. So it should be enough to prompt you. I'm going to update the repo over the next week or two with some more functionality, some more examples. I haven't put the second bounded context in yet, but they will be coming soon. But DDD is hard to get started with, so don't pressure yourself. And there's no generally absolute right way to do things, and you have to make your own decisions and understand the trade-offs that you're making and the reasons why you're doing stuff. And you can follow me on Twitter and you can ping me questions if you like. I'm at Nealio82. And I want to give a quick shout out to Ed Mann, Lucas Curo, and Jim McLean, who took time out of their busy schedules to proofread my slides and listen to my talk and to give feedback. And thank you to you as well. for taking time to watch my presentation. I do hope you found it useful. And the great thing is that Alessandro is doing hexagonal architecture next, and I think you're going to see a lot of that overlaps with what we've got here. And the hexagonal architecture goes hand in hand with domain-driven design. So I'm really hoping that it's going to solidify a lot of the concepts that we've done today, and hopefully what we've done here as well is going to give you a kind of springboard into hexagonal architecture. I think that's going to be really fun. So thank you everybody for listening to me, and I hope you have a wonderful remainder of the day.
Thank you very much, Neal. That was amazing.
Thank you. My headphones turned themselves off halfway through that, so I'm gonna
oh, that's great.
show everybody my lockdown haircut now.
We've got some interesting questions and even discussions going on in the chat.
Cool.
One of which is I think very interesting. Because you were talking about how the code should use the same words as the company.
Yes.
But now there's some issue here for people that are in a company that is not English, because developers usually use English language, but the company may use their own native language. What do you think would be best, to use English or to use the native language in the code?
Well, I saw a really interesting discussion about this on Twitter just the other day. And I think the general consensus was, I think I saw some Brazilian developers, because they speak Portuguese. And their outcome, I think, was that they do the business stuff because the business speaks Portuguese. So they have all the domain terms in Portuguese, but the infrastructure stuff in English. So right. I mean, I don't know any Portuguese words, so I can't really give an example. But they said it's sometimes a bit weird where you see with those repository things, you'll have half of it, the first part of it in Portuguese maybe, and then like whatever class or exception in English at the end. But that's just what works for them. Now, the key thing is to decide what language does the business speak, and what works for you. If most of your developers speak English, or if you're used to doing everything in English and you're comfortable doing it in English, and you think that the business is going to do that, then sort of moving forward, then maybe it makes sense to do that. But it depends a hell of a lot on your own individual situation. But I think from this Twitter thread that I read, I think it's perfectly sane to keep the business stuff in Portuguese, because more people in the business will understand the concepts that are happening, and you don't lose meanings of things in translation between English and the native language than if you do it that way, and then just keep the infrastructure stuff in English. Okay, that makes sense, because, well, yeah, if you want to use the same words that are used in the business, use the same language. Okay. Let me check. There were some questions about how to deal with entities in different bounded contexts, and also that it could happen that there could be inconsistencies between different entities in different bounded contexts that are related to the same database table. Could you elaborate a bit about that? Well, I mean, the thing to do is keep stuff separated, right? So if you've got two entities in the same database table, you probably want to separate that out, have them in different database tables. Certainly in Postgres, you can create separate schemas for each bounded context. You can keep it in the same database, but you can create separate schemas. I don't know if MySQL supports separate schemas actually within the same database, but I don't think so. Yeah, the key thing is keep it as separate as possible. Don't. It would be useless to separate your concerns at the code level just to mash it all together again at the database level. So keep things separated as much as possible. Even have a different database server. You sort of take it to the extreme. Have a different database server for each bounded context if you need to do that to separate it. But certainly try to, you could, if you wanted to keep everything in the same database, you can prefix your tables with the name of the bounded context or something, or the name of the aggregate. But how do you handle the relations between different entities when they are in different bounded contexts? Sure. If you need entities within different bounding contexts to be able to communicate in some way, you can emit events. You can have stuff. I mean, I'm talking about at the application layer, sorry, the application code rather than at the database level. But you can get your bounding context to emit events, and you can listen to those events from other bounding contexts. Now, I didn't go too deeply into that because I wanted to get the basics of stuff like the data in and out today. But there's certainly much more reading that everybody can do once you're familiar with the kind of basic pattern of stuff. But a lot of the time you would have stuff communicating via events. And this is how event source systems work as well, where you can have like something, create an event over here, and something else over here kind of going, oh, well, I know about that. I don't know anything about the code over here, but I do know that there's an event that I want to listen to, so I can update myself over on this. I'm trying to keep within my webcam here, so that I can update stuff over here. And this is, so the key thing is to communicate via events and split those relationships and those entities out of the database. Don't have them depend on each other for a starter. You can always make it more complex again later on if you want to, once you're more familiar and comfortable with domain-driven design.
But how do you handle that in terms of when you use, for instance, if you use Symfony, most people use Doctrine. How do you handle that?
Well, I mean, I would say it's so in the examples that I had earlier, like I specifically stayed away from mapping stuff with Doctrine in the domain layer, because you bring in mess into the domain when we should be thinking about keeping it clean and not mixing concerns together. Now, Matthias Novak wrote an article about mapping domain entities with Doctrine, and he made a good case for it. But I think you have to understand the trade-off that you're making to do that, and it does have the potential to bring mess in. You want to keep these classes clean with clear boundaries, and to bring the ORM into that, or to map with Doctrine, brings in a lot of potential straight away for mixing stuff up and not being able to keep the clear boundaries. So I think my immediate thought would be to try to not use the ORM within the domain. Don't use Doctrine. Just use the DBAL connection, or even PDO if you want to go a step lower and get rid of all the logging and stuff that Doctrine gives you. I think try to keep Doctrine out of the domain and just in the app layer to begin with, and then think about bringing it in later on once everything's a bit clearer.
Okay, right. There's another question. One of the issues of applying DDD to an already existing application is the transition phase, where you start from a regular CRUD-ish application to one that uses DDD. I'd love to take some time and find all the business rules scattered throughout the code, but realistically that can't be done, so it must be applied gradually, which means the app becomes a weird mix of architectures, and it's kind of difficult to coordinate people during this phase. Do you have any suggestions on the matter?
Yeah, of course. I mean, you can just move your entire app right now into an app subdirectory, and then nothing changes. You do the config changes that I showed you earlier at the beginning. That all stays working the same. Anything new, you move piece by piece into your own bounding contexts. So any new stuff comes in, you just map it. So you create it in a domain. Instead, you create your application services and talk to stuff in the controllers through that. If you need to rely on any information from your CRUD system, you can just send that through from the controller. So if you needed to have some sort of identifier for something in your CRUD system, just send that through as a property. If you've got a UUID or an integer or something, or even an email address from a user that you need to send through, just send it through as a native type and store a record of that. And you've got, you're starting to move those concerns into the newer system, into a new database table, but you maintain compatibility with the previous system. Right.
There's a simple question. Where can we find the slides?
The slides, they are all, I will upload them to Joined In. So I think there's a Joined In link for this. I will upload them. I need to export them as a PDF from Google Slides, and then I will send them up onto the internet for you.
Okay, that's great. I think that will be it. Thank you very much for your time, for sharing your knowledge on DDD in Symfony.